All right, everybody, welcome back to the channel and welcome to today's video. And boy, do I have a good one for us today. Have you been using the right infill pattern for your project? How do you know? What are the differences in all 17 of the different types of infill patterns that are available for us in Bambu Studio? I didn't know this, and it came up on stream the other day of some of the cool patterns that people were using in their for their infill, and it got me thinking. Well, what is the difference for them, and what are they used for? So I did some digging for us, and I found a couple of items that may be useful for us as we're thinking about these infill patterns making our perfect 3D printing project. So today we'll go over all 17 of the different infill patterns, and we'll look at a brief description. We'll take a look at it. I printed some samples of each one of them. We'll look at a possible use case of when you might want to use that infill pattern, some pros and some cons. We'll look at how much the variance in print time is and how much variance there is in the material that's used for each of these different infill patterns. So I did make a box that's 70 millimeters by 70 millimeters by 70 millimeters, and I stopped it at the 60th layer, or right around the 60th layer on each one, so that we could see the cool infill pattern that it made on there. We will look at each of the print times for each one of them for a 70 by 70 by 70 cube, so that we can look at the differences in how much filament it uses and what it does to the print time, if it makes it shorter, if it makes it longer, anything like that. By default, Bambu Studio uses the grid infill pattern, so we will go over that one and see why it may be used as the default, but then we'll go over all of the other ones in there as well. So if all that sounds good, then sit back and relax and I'll get everything ready. All right, so here we are in Bambu Studio, and we'll be looking over the sparse infill patterns today that are located under strength right here. So you'll see that there's 17 of these in here that we'll be going over today as the infill. And as a reminder, the infill is the pattern that is used to fill in the solid objects, right? So instead of, printing and using a whole bunch of material to make this thing completely solid, which may not be necessary, you can put an infill pattern in there to save time, as well as to save on the amount of filament that you're using for this. The infill pattern does affect the strength of the object. Maybe it's shear strength, it's compression strength from the sides, and different things like that. So each one of these does have an effect on that and will change as your objects change, and as you change these different infill patterns, the properties of them will change. And we'll go over each one of these, and I'll give you a couple of real brief suggestions on when to use them and what the pros and cons of each one of these are. The other thing that I want to call out is just above here on the top and bottom shells, you can use some of these patterns as a top surface pattern or a bottom surface pattern, or as an internal solid infill pattern. So you can actually change, it doesn't have all 17 of these, but some of these different patterns that we'll look at today are also available as a top or a bottom pattern. So if you want a really cool pattern on the top of your print or on the bottom of your print, look at some of these as an option to do that. I would also suggest go ahead and print out and do what I'm doing today. I'm printing out this cube. It's just 70 millimeters cube, but I'm stopping right around layer 60. And that way we can get a peek inside of these. And I'll show you, I didn't get it exactly on 60 on every single one of them, but I'll show you, what it looks like on the inside of each one of these. And that would be similar to what it would look like on the top surface pattern or bottom surface pattern. So I would recommend printing some of these out that you find interesting, just so you have a sample there that you can look at if you want to use it for a top or a bottom pattern. All right, so all I'll be doing today, I won't be changing the density or the anchor, any of that stuff, and that will affect, the infill that you're using in here. So changing these things, and some of the printing tips that I'll give on some of these patterns is, to adjust the density and different things like that, may help with the print and may help with it filling in the infill. I won't change any of that stuff. I'm only going to change the infill pattern and then hit the slice plate. The numbers that I'll be using for that will be this number right here, and the amount of grams that it's using right here for each of these prints. So I'll go through here and change all of that, and then I will let you know how it affected the print time, the total print time for the cube, even though we won't be printing out the entire cube. Okay, so if all that sounds good, then let's dive in and start looking at the different patterns. All right, so let's see what was printed out. And the first one that we'll look at is concentric, and concentric infills are circles or shapes that move outward from the center point. Right? These are ideal for circular objects or when a unique top layer finish is desired. These have a unique aesthetic appearance. That's the pro. The cons of this, it may not offer consistent internal support. Printing tip: ensure your model's geometry is compatible with this infill to avoid potential gaps. Now, the printing time on the cube for this one, so for the full cube, would be 1 hour and 6 minutes and using 70.84 grams. Next is rectilinear. Rectilinear consists of straight lines running back and forth in a single direction, changing directions in each layer. The use case is for general purpose printing. The pro, it can be quick to print. Not the strongest pattern would be the con, and use higher densities for improved strength if this is something that you want to use for general printing. The print time for the cube was 1 hour and 4 minutes, and it was 70.45 grams. One thing to note with this is it is not very flexible. It is pretty rigid, and it is fairly light. Next on the list is grid, and like rectilinear, it's like rectilinear, but lines in both X and Y directions, creating a grid. This is what the default is on Studio, and it is used for general purpose printing with a balance of speed and strength. The pro is it is relatively strong. The con is it consumes more material than rectilinear. And a printing tip for this is adjust the distance for optimal strength and material usage. The time that it took for the cube to print was 1 hour and 2 minutes, and the material it used was 68.91 grams. So you will see a little bit faster than rectilinear and a little bit less material used for this particular cube here. All right, next on the list is line. And the description for line is parallel lines without alternating directions per layer. The use case for this would be for simple parts with minimal strength requirements. The pro of this is it's faster to print. The con is it has the least internal support. This is best for draft prints or non-functional parts. That's the printing tip. This took 1 hour and 3 minutes and used 68.75 grams of material for this particular cube. All right, and next is cubic. And cubic is 3D cubes that rotate orientation with each layer. The use case are parts that require equal strength on all sides or in all directions. The pro is multi-directional strength. The con is it consumes a lot of material. And the printing tip is consider infill density based on the strength that you need. This did take 1 hour and 4 minutes to print with 68.77 grams of material for this particular cube. All right, so next on the list is triangles. And the description for this is triangles tessellated across the plane, as we can see here. Use cases, objects needing enhanced shear resistance. So if you need something that can handle, being ripped apart or twisted this way, you'll notice that it is very, very strong against shear resistance. The con is it's slower than rectilinear. And printing tip is this is ideal for mechanical parts under tension. So if your project is mechanical parts that are under tension, then consider using triangles as your infill pattern. And this particular cube took 1 hour and 5 minutes to print, and it took 69.94 grams of material. Next is the trihexagon. And this is a combination of triangles and hexagons. The use case for this is a balance between aesthetic appeal and structural integrity. The pro on this is its good strength with a unique appearance. The con is it's more complex, hence a little bit slower to print. Printing tip, this works well with translucent filaments. So maybe that's something that we'll try with our clear filaments that I haven't tried before. And the printing time for the 70 by 70 by 70 cube was 1 hour, 4 minutes using 68.3 grams of material. All right, and next on the list is gyroid, which is a complex sinusoidal waves in 3D space. And there'll be a quiz at the end. Everybody needs to know what that means. Just kidding. So this one you can see has some really unique shapes that are in there. And the use case for this is parts that need strength and flexibility. And the pro here is isotropic strength. And the con is going to be longer print times, and it does affect the print time, but not so much the amount of material. On the printing tip, monitor first few layers to ensure proper adhesion due to the complexity of the pattern here. So it did take about 1 hour and 30 minutes was the print for the full cube with 67.26 grams of material. So as you can tell from the other ones, around the same, maybe a little bit less material that it's being used to print in here, but it did add about 25 minutes of time to the print. All right, next on the list is honeycomb. And a honeycomb is a hexagonal pattern resembling a bee's honeycomb, as we can see here, right? The use case is structural components requiring weight efficiency. So the pro is excellent strength to weight ratio, and the con is it is longer to print, and one of the longer ones to print. Printing tip, ensure proper extrusion multiplier for this intricate pattern. So for the cube, to totally print 1 hour, 56 minutes using 81.31 grams of filament. So as you can tell, it added a lot of time to the print as well as a lot more material to it. Okay. Even though it has excellent strength to weight ratio, it is going to use more material to do that. But if you do need that strength, this is the way that you're going to get it. All right, so next on the list will be the adaptive cubic. And this is similar to cubic, but adjusts density based on the model's needs. And the use case here is going to be complex models where varying strength is needed. The pro is this is a very efficient material usage. The con is it requires slicer to compute adaptive patterns, increasing slicing time. So this will increase the amount of time or how much horsepower your computer needs to slice the model. A printing tip, ensure your model has been properly analyzed before slicing. For this particular print, it only took 54 minutes for the entire cube, and it took 57.15 grams of material. All right, next on the list is the Align Rectilinear. And this is a rectilinear patterns that don't alternate direction with each layer. So you'll see they run all in the same layer. This is great for rapid prototyping. It's faster to print than standard rectilinear. The con is it is weaker interlayer adhesion, and a printing tip is ideal for non-load bearing parts. Okay, so quick to print, non-load bearing parts. For the cube that we're testing today, it took 1 hour, 5 minutes. It's 70.45 grams of material. Next is 3D Honeycomb, and this is a three-dimensional evolution of the honeycomb pattern. Use case objects requiring strength in all three dimensions. The pro here is multi-dimensional strength. The con is it does take longer to print as it is the longest one on the list. Ensure nozzle is properly calibrated to handle intricate patterns, and that's the printing tip there. Print time on this one was 2 hours and it used 72.67 grams. Next is the Hilbert curve, and this one has a really cool pattern. It almost looks like a maze. The description here is a continuous space-filling curve in a 2D plane. The use case is aesthetic projects or when a unique top layer finish is desired. The pro is it's a unique appearance. The con is it's not the strongest. And the printing tip is this is best suited for models with larger flat surfaces. So this one did take a little bit longer than most, but not the longest. It took 1 hour and 33 minutes, and it took 69.35 grams of material. All right, next on the list is the Archimedean chords, and that one has the coolest name. And the description here is spirals spaced evenly from a central point. And the use case here is aesthetic pieces or top layers. So this might be something that you put on a top layer. It is a option for top layers as well. Pro is an eye-catching design. Con is it provides less structural support. A printing tip for this is it works well with top layers for a distinct finish. Okay. Print time on this one was 1 hour and 4 minutes, and it took 68.44 grams. All right, next on the list is the Octogram Spiral, and this is a 8-pointed star pattern spiraling from the center. Use case is decorative objects. The pro is it's visually appealing. The con is less support than conventional patterns. Printing tip, ensure smooth extrusion to maintain the beauty of this pattern. It took about 1 hour and 18 minutes to print with 69.61 grams. Support cubic is the next one, and that is a cubic pattern optimized for support structures. Use case is parts with overhangs or complex geometries. A pro for this type of infill pattern is it provides optimal support with efficient material usage. Con is specific to support structures only. Printing tip, adjust the support density for best results. For the cube, it took 45 minutes and 43.83 grams of material. All right, last on the list is lightning, and I thought it would have little lightning bolts in here, but it doesn't, and let's listen to the description as to why. This is optimized for speed, so it uses a combinations of lines and minimal touch points. The use case for this is rapid prototyping where internal structure isn't critical. It's extremely fast to print, but offers minimal support. As we can see, there's nothing in here. Printing tip, used for draft prints or internal prototypes. So this isn't something that I would use for a finished print, but definitely for a prototype. And it did have the fastest printing time, as you could imagine, and the least amount of material usage, as you could probably guess. And that was at 40 minutes of print time and 30.19 grams of material used if I were to print the whole cube there. And keep in mind that some of these that are adaptive and ones like this may not show the same pattern here as they may on larger or smaller, different shaped objects or whatever. I just wanted to use the same consistent object between all of them to see what those results were. And that was the results there. All right, now that we've looked at all of the different infill patterns that you can use, hopefully this gives you some ideas of when and where you need to use those different infill patterns, and hopefully it sparks some ideas for some creativity. I think some of them that are available as the top and the bottom layers are really, really cool, and something that can add that extra special little touch to your project. So I definitely would recommend printing out some samples of these, messing around with the density and different things like that, so you can really dial in that perfect print, both in the infill pattern as well as in the top and the bottom surfaces as well. So couple of them that I wanted to call out as being really cool. The first one would be the adaptive cubic. And that one is something that I will probably use more and more in the future because it's very efficient on the material usage. It didn't add much time to the print, and it is very strong. I cannot move that thing at all. So adaptive cubic was one that stood out as a really good one to use. Probably the coolest looking pattern is the gyroid one, and that one looks really, really cool. It does add to the print time. It doesn't add to the amount of material that you use, but I thought that one looked really cool. And then lastly, the one that I wanted to call out is the 3D Honeycomb. So do take a look at this one. All right, so that one looks pretty cool, but the thing to notice with this one, and I didn't show in the review, is it does twist pretty easily. I don't know how well you'll be able to see that. Super strong in all of these directions, like I said, in the 3 dimensions, but it twists. Print one of these out and see for yourself what I'm talking about. That's pretty cool, and that might come in handy in some of your projects. So hopefully today's video was very informative to you, and you enjoyed looking at all of these different infill patterns, because I sure did enjoy making this video, as well as printing all of these out. So if you enjoyed today's video, be sure to hit that like button. Make sure you subscribe for my future videos. And I appreciate everybody watching to the end, and I hope everybody has a great week. Thanks, everybody.